Welcome to another installment of Tinkering with Electronics. Larry and I just got back from Dalton, Georgia, and we both came away with things that we had to ask ourselves on the way back, why in the world did we buy these things? But at any rate, I did a little better than he did, or maybe a little worse than he did, however you want to look at it. He came away with a few things that he probably didn't need. And I think I only came away with one thing that I didn't need. This thing is called the Heathkit Harmonic Distortion Meter. It's model number IM-58. I was more curious than anything, and for $15 I was more than glad to take the risk. And I felt like the meter and some of the parts and switches were probably worth at least that much. But I kind of got interested in it after finding the manual, and I started working on restoring it. So we're going to turn this on in a minute. I have an old Zenith amplifier here that we're going to try it with, and we're going to see what it does. So stay tuned. Folks, what we're looking at right now is a Zenith 5R20 chassis. I'll slide back just a little bit. What I want you to see from this is, look how yellow this chassis is on this thing. Everything about this whole thing was really yellow. I restored quite a few radios, and I don't believe I've come across one that had so much smoke damage or smoke on it. This thing is just amazing to me. I have it on right now, and what I want to do is I want to show you what we're about to do using the Heathkit Distortion Analyzer. So I want to move this chassis over just a little bit and get it out of the way so we can see what's going on in the background. But before we get started with that, let's take a look at the schematic and see what that's going to look like. So what we're doing is we're going to I'm injecting a signal right here with an audio generator. And that audio generator is going to feed a clean sine wave all the way through and then out. And at this point right here, we'll enter into the Heathkit Harmonic Analyzer. So let's look at the equipment that we've got. I've got an old Heathkit audio generator that I bought. Don't know why I needed it either, but I wanted to restore it, so I bought one, restored it, and right now I have it with a multiplier of 10, and I have it with a cycles of 10. I mean, that's 100, so that means I'm putting out 1,000 kilohertz or 1 kilohertz coming through this wire right here, and then that wire is coming up and going into the amplifier right here. And this is the front end of the amplifier. I've added a miniature jack in there so that maybe I can figure out something to use this for. I don't care for phonographs, but I believe that I may can have some use out of the amp. I have a couple of capacitors that I still need to replace in this, but I began playing with it probably a little bit early. I didn't want to pull the cans out. There was so many connections to it that I just simply made a filter capacitor rig right here. Okay, let me get this turned around, and what happens is, so I have a signal coming in here. It's coming all the way through the amplifier. And right here is where the speakers come out. And what I've got on here right now as a load, I have about 4 ohms of resistors right here. They're not even warm, they're still cold, of resistance right here to act like the speaker so you don't have to listen to that 1 kilohertz tone. In addition to that, I have added the Heathkit Distortion Meter. Its cord is running right here and coming into the distortion analyzer. So that's where we're at. Now we're going to set this distortion analyzer up per the instructions. And first thing that they want you to do is they want you to put it on set level. Okay? So I have that on set level. You have two choices. And then they want you to take the level and they want you to raise it up until you get a full scale reading right here. So we'll raise this meter up and give you a full scale. What I want to show you that's happening is I want you to look up at the oscilloscope that's hooked up to the output of this thing, and I'm going to raise that level up and notice that I'm getting a signal rising up. Okay, so I've now got that pretty well full scale. I'm going to lower this just a little bit, and this is my nice clean 1 kilohertz signal coming out of the audio generator. Okay, now let's see what we're going to do with the signal from there. Now, per the instructions, once you have that set up like we've got it, the next thing they want you to do is they want you to set it to the frequency range that you want to work in. We're going to be working on 1 kilohertz, so that's going to be between 200 and 2000 kilohertz. And I want you to notice what this meter does when I begin adjusting. So I'm going to go to 200 to 2000, and there's a tuner on this thing. And all this is a notch filter. And if you'll watch this, this has got a mechanical connection between this knob and here. When I begin turning this, I want you to watch that meter. As I get closer to 100, which is actually 1000, as I get closer to 1000, notice what the meter's doing. We're trying to go down until we get it as low as possible. All right. So I think that's about as low as we can go. The next thing they want you to do is use this balance to do the same. And then you can turn the sensitivity down. Now I want you to see what the oscilloscope looks like now. See, we've all but done away with that signal. Now let's see what happens when I knock this sensitivity down. We're going to see the meter rise a little bit. That's 30%. Excuse me. That's 10%. There's 3%. Hey, we were able to get all the way to 1% with this. Now we're going to begin dialing again and see if we can lower this. This is going to be really touchy now. Real touchy. Lower, lower. We've kind of magnified in on the signal is what we've done. All right. That's taking care of that. Now let's come over here and adjust more. Using the balance, I'm getting a little bit more out of it. Now let's adjust again here. All right. Now let's adjust here again. And you're trying to get the lowest you can with these two knobs. I think we're about there. Okay, I believe that's good enough for demonstration purposes anyway. Excuse me. Our weather has been changing. As Larry showed you on the film of Spring City, we wound up with all kinds of flooding, and I think it's wreaked havoc on my sinuses, so it's making my throat not be clear. Now what we've done is we've taken that 1 kilohertz signal that we originally started with, and we dialed it to 10 on the 100 scale. And I'll turn it back to the 100 scale to let you know what's left of it. And this is all of the amplitude of that signal that's left. So I'm going to put it back on 1% because we're able to magnify in. Matter of fact, I'm going to leave it at 100 so you can see what we result. You remember what the oscilloscope looked like? We had that nice, pretty sine wave. The sine wave is now gone. Now I'm going to start dialing in using the sensitivity meter here, sensitivity switch, and let's dial that in and see what the result is. Starting to get a little waveform, a little more. I'm on 10, I'm on 3, and now I'm on 1%. Folks, this is what's left after you've taken away the 1 kilohertz fundamental. This is the distortion that's left. Now please understand, this is really small, as best as I can understand this. Some of you out there can make comments and can help me understand this a little bit better. Remember, we're tinkering with this. We're just learning. I'm not an audiophile. I just find this is kind of interesting. But we've done away with the 1 kilohertz primary, and it looks to me like, as I watch this change, that we're looking at some sort of harmonic that's going on here. And we might look at that a little closer in another mode in just a moment. So this is what's left after we've magnified it up a whole bunch. And this is the distortion that's coming out of our little smoky amp over here. So I don't know whether this is good or bad, but it looks kind of good to me, being that I don't have that much competition, I think, with the primary. So I'm going to be right back. We're going to try looking at this under another mode of operation, and we're going to learn a little bit more about a digital oscilloscope as well. What we're looking at again is that 1 kilohertz signal, and we're seeing what that looks like on this screen. We're going to flip this oscilloscope to another mode of operation. I learned that these things actually have kind of a basic spectrum analyzer in it, and I find it pretty handy. So let's see what we discover with our signal when we go into what's called FFT mode. And I'll let you look up FFT on the internet, and you can read about it, and it's a mathematical thing that these scopes can do. So let's take a look and see what happens. Okay, in this particular scope, I go to Math Menu, and when I go to Math Menu, I have lots of choices that I can do, one of which is called FFT. And what we're going to do is, if you can see this right here, that says 40.3. And let me try zooming in just a little bit and see how that works for us. Okay. I hope you can see this on the camera. That should be good enough. All right. Right now, this is saying 40.3 kilohertz. I'm going to make an adjustment to the time knob over here, and all we've done is we've taken the oscilloscope from amplitude per time, we changed it into amplitude per frequency. So this is frequency running along here, and I'm going to change this frequency by using the seconds and division knob. So let me make a change here. Excuse my arm. And we're at about 10. 4, 2, there's 1 kilohertz. And I hope you can see that 1 kilohertz signal. Now what I'm going to do is I'm going to go through the setup process again. I'm going to lower this level, and this time, instead of you guys watching this meter drop, I want you to look at this fundamental signal. And I'm going to get it out from behind this cursor up here. I'm going to get it out from behind this cursor. So I'm going to move it over just a little bit. There we go. And hopefully you can see that real well. I'm turning the tuning knob now, and you should see it begin shrinking here any moment now. You see it shrinking? What we're doing is we're notching out that fundamental frequency. When I get closer to 1, I should be about there. Now this is as low as I can make this go. Okay, so we knew we saw a lot of garbage on the screen. Well, the garbage isn't right here. What we're going to do is I'm going to move over a little bit again, and we're going to look over in the higher frequency areas and see if we can see where all that garbage was. And we're seeing some stuff coming up off the floor here. That's called the noise floor. Let me raise that up just a little bit. So we're seeing all this extra noise coming in. and I'm up to about 20 or 44 kilohertz right now. Let me go back down. It's 22 kilohertz. There's 4, and there's all this noise along here. What I'd like to do is get myself as close to 2 as possible. So I'm moving it. I'm looking for that center line. So I'm trying to see if it's the second harmonic that we're seeing, but it doesn't look like it's a second harmonic. It looks like it's something else. It's above and below that. But anyway, this is called FFT mode. If you've got a digital scope, it is something that it's useful for, and you can kind of see what signals look like and how they act. Now I'm going to be right back. We're going to do one more tinkering expedition with this, and we'll see what things look like from there. So I'll be right back. I've added a little bit more to our rig. I didn't feel like we had enough jumpers. So I've added a small audio amplifier, and I apologize ahead of time. It's going to be a little bit loud what we're going to do next. But I read about this morning about you should not only hook up your oscilloscope and look at the distortion, but you can also put it on your shop monitor and listen to the distortion. And I did find it interesting. It's not as revealing to me as I thought it would be, but you all make comments and we'll sort this thing out. Okay, so what we're going to do is right now I've got the notch filter set so that we're getting the 1 kilohertz tone all the way through. So what I intend to do is I'm going to turn on this little amplifier, and when I do, we're going to hear that tone in the background, and I'm going to then quickly, so that you don't run through your house with your hands over your ears, I'm going to quickly tune out the fundamental. But what I want you to hear is, I want you to watch the oscilloscope, and I want you to hear the difference, and you'll hear that harsh sound that you're going to get, and that'll be the distortion that's left after we do this. So let's take a shot at this and see how it works. All right, so I've got you now focused on the oscilloscope. We're going to zoom in on that oscilloscope a little bit, and it'll take me just a minute to reset the camera again. All right, so you're looking at the full signal. And as you tell, I'm not turning the speaker on yet. I'm going to begin moving it toward the distortion. And this is what's going to be left of that. So let me bring that back up. You can see what it is. Now I'm going to turn on the amplifier. This is the 1 kilohertz tone. I'm tuning it out. Now listen carefully. This is the garbage that's left after the fundamental's been removed. I'm going to turn that back off. Anyway, that's the garbage that's left after that fundamental is been notched out. And to me, that's kind of interesting. Again, don't know what I can do with that information, but this has been kind of fun to play with it. There's a lot of criticism over this Heathkit Distortion Meter, but you know, I've got 15 bucks in it. I think I'm getting more than $15 worth of play out of it, so the tinkering alone is worthwhile. And it wasn't a whole lot to rebuild it. It was like 4 capacitors that I had to change. There's probably a few other things that need to be done to it. I did change out 1 resistor that was way out of value, and I got 1 more that needs to be, but I have to get that one. In addition, I wanted to introduce this Heathkit audio generator. Frankly, I don't know that I go rush out and buy one of these. I paid way too much for it, I'm sure. But again, it was something for me to tinker with. I rebuilt it. What it does is it produces seems to me, a harmonic-free sine wave. Unlike this Lodestar up here that I have. Unlike this one that produces lots of harmonics, this one produces nearly none. So already I could see some use for it if you're trying to see what happens to it on the other side. Frankly, do I need this distortion meter in order to decide that? No. I found that actually I could look at the signal through the oscilloscope and you could see the garbage that one of these amps puts into it, and it was kind of revealing to me, but it's been fun, and that's what this is about for me. It's tinkering. So if you've got any comments to help with this feel free to leave them down below. If you have questions, I'll try to answer them. If you have another setup that you'd like to see, by all means mention it. We'll try it. Enough for now.